Anything that we think we've got in terms of computational intelligence is still a feeble and very, very, very primitive version of what happens in nature. I do think there's a lot of hubris and sometimes naivety from computer scientists who think they've actually developed human-level intelligence. They seriously haven't. You have to understand, just because we can talk doesn't mean we're better than a tree. We're just different organisms. We've all evolved for the same amount of time on this planet. We're all equally good, because we're all here, we're all equally good at solving the problems of staying alive.
Today I'm speaking with Peter Bentley, an honorary professor and teaching fellow in the computer science department at UCL. His research focuses on evolutionary algorithms, but he's also an entrepreneur and inventor, creating the iStethoscope app when the App Store first opened to developers. Incredibly, this app worked better than some of the commercially available digital stethoscopes at the time. Welcome, Peter.
Hi, well, thanks for having me.
Glad to have you, yeah. So, by your own confession, according to one of your TED Talks, when you first created the iStethoscope app, you didn't know much about hearts or stethoscopes. So how was it possible that a lone researcher such as yourself was able to create something that could compete with commercially available digital stethoscopes?
Well, I mean, probably because it's quite simple. So, a stethoscope basically amplifies very quiet sounds, and but obviously it's helpful if it can do low frequency sounds for the heart, but also higher frequencies for things like breathing. And I was just experimenting. This was the first time anyone could write software for these iPhones, and I just discovered they had really good built-in microphones. And when I added a little bit of filtering, I mean, I knew a little bit of audio processing. So I added a few software filters that I created myself and amplified the small signals that we were getting from the built-in microphone. And yeah, discovered, oh, we can listen to the heart. That's cool. So I just called it this iStethoscope, and I was quite surprised when I got all these auscultationists, or whatever they call themselves, but basically people who are very good at listening through stethoscopes and understanding the sound. They got in touch and got very excited. So we ended up extending the app and doing a medical trial and
Wow.
doing all kinds of competitions across Europe for machine learning, which helped progress kind of automated triage of heart sounds. But yeah, mine was one of the very first ever medical apps on the App Store. It did go to #1 in the store.
It beat Angry Birds.
We did beat Angry Birds. Angry Birds was around even then. And yeah, we ended up creating this big crowdsourced database of heart sounds, which people still use to this day in research. So that was nice.
So does it say something about the medtech industry in general that you were alone able to make substantial progress on this, or what it turned into a collaboration in the end, or was it about this particular problem that just happened to be?
I mean,
amenable?
it was. Well, I was first. I was by no means the last. And once I kind of demonstrated it was possible, then a lot of other stethoscopes and a lot of copycats came along rapidly. But I just happened to be the first. I can't claim I was a genius at this. I was just happened to be there at the right place at the right time, and it did get a lot of publicity. It went on a lot of TV channels and all over the world. But I mean, I like to think it did some good too. I had some reviews from some users, and one of them was lovely, saying that she had a baby that was in trouble, and she'd used the app a few days before and realized it wasn't sounding great. And when she went to a specialist, the specialist said, well, how long has the heart sounded like this? And she said, well, I used this app and it was sounding like this 2 days ago. And they said, oh, this is really serious. Next thing she knows, she's in a helicopter going to a hospital, having an emergency C-section, and the baby was fine. But so things like that. You hear stories about how these apps can save lives. It's unexpected, but really nice to hear.
So is this app, you said you did a medical trial. Has it been medically accredited?
No, that's kind of where we hit a brick wall all those years ago. I mean, I don't even have the app available anymore, to be honest. But back in the day, Apple were really quite resistant about their devices being used for anything to do with medical things, because they did not want their phone to get tangled up in should an iPhone become a medical device. Since then, they created a lot of regulation. They kind of figured it out. Although, if you read the regulation, the FDA regulation about medical devices for software, guess what kind of app they mention? They mention a stethoscope app. But anyway, they figured it out afterwards. But at the time, it just looked like a complete nightmare that if I actually wanted my app to be used as a proper medical device, it would have cost a fortune and it would have been years going through lawyers. So in the end, I didn't, and it was left as a useful utility, but I could make no claims formally about its medical utility.
Yeah, I can see a parallel there nowadays with large language models and people using them to work through their emotional problems effectively as therapy bots. And these chatbots are certainly not medically accredited to
No,
perform in that way, but they can still provide enormous value and also come with the risks of, I think it was, what was this, teenager Adam Rayner, who commits suicide with the help of
yeah,
ChatGPT to help plan it.
yeah.
So how do you balance those two kind of things where you can provide value before properly mitigating against the risks? And like you said, your user was able to have a tremendously successful experience with her
Well,
child.
I work with trained specialists. So very quickly after my initial version, I was working with experts who deal with auscultation. And one of the earliest things they recommended was I actually have a warning straight up that for example, if you have a pacemaker and you start putting a phone too close to it, it might affect its behavior. So I had to do that kind of thing. So there's a
Hmm.
lot of things that a layperson might not know, or a computer scientist may not know. So I worked very closely with the experts, and even though it wasn't formally a medical device, I knew how people might use it, and so we did our very best.
Yeah.
In terms of large language models being used in that way, I'm dismayed that things have gone the way they have, and I mean that's a longer conversation perhaps, but I do feel a lot of today's AI is being misused.
Yeah, I think we'll touch upon that later in the conversation. But for now, I'd be interested in hearing what you've been working on since then, or some recent work that you're excited about.
Well, there's never a short answer to that sort of question. Lots of stuff. I mean, in my lab, we've always focused on trying to understand how nature solves problems. So we do look at things like neural networks, but often in terms of spiking neural networks, or perhaps in terms of how the brain repairs itself after damage. So I've got PhD students looking at both of those areas at the moment. We're also looking at large language models and how there's an interesting contrast between the creativity that you can get out of, say, an evolutionary algorithm, like a genetic algorithm, and a large language model. So we've for years, for decades, we've used genetic algorithms as amazing sources of creativity. They don't have any existing data to guide them. Typically, they'll have a fitness function to tell them what's good or what's bad. But they're not influenced by existing data. They're just influenced by what works and what doesn't work. And that's kind of how nature does it. Nature is not exactly influenced by the ideas of other people. It's just builds on what it's got already and tries to make something that works. Whereas large language models are quite the opposite. They are only influenced by what they've seen, and they put together things that they've seen. And so when we actually try to get quite creative results out of a generative AI system, it's actually really difficult, because it's always, it always gives you the most likely result for a given prompt. It's by design. It doesn't want to be too crazy, because it'll probably hit one of those guardrails. So it's always safe, and it's designed to be safe and inoffensive, and give a sensible answer. But if you want creative answers, you're at the edge of that. You want to push the boundaries. You want to have something a little bit different, or quite a lot different. Yeah, we really struggle with that. So we've been trying lots of different ways. Can we make an LLM brainstorm? And the answer is not very well. Can we make a generative, an image generative model generate really creative images? That can be quite difficult too. For certain, if you narrow it down for things like architecture, with a bit of help you can. But to be honest, the best result we've had is combining a genetic algorithm with a large language model, and use the GA to kind of force the generative model into its discomfort zone. Getting it thinking outside its box a little bit. But even then, you push it a little bit too far, and it just refuses to do anything, because it hits those guardrails again. So there's a real conflict between getting a creativity and something different out of today's AI, and having a safe and inoffensive and answer. And we see the same thing. You want to use an LLM to pretend to be different personalities. It's very bad at it, because real people are quite offensive. Different personalities in their own way. Everyone sometimes is a little bit rude, or a little bit, not quite politically correct sometimes, even if they don't mean to be. LLMs are always safe. Unless, of course, you go for the dodgy ones, in which case they're always unsafe. But it's very hard to it's very hard to get coherent representations of differences and outliers in today's AI models. It doesn't do outliers. It does safe middle ground, like a committee. It always gives you that safe average.
So this is not really a limitation of the tech, it's a limitation of the guardrails placed on the tech.
No, it's also how it works too, though, because of the way it's predicting the most likely result from a given prompt. It's not predicting the crazy outcome from a prompt, because then it'll be useless most of the time. You want a good software example from a given prompt. You don't want a crazy one. You want something that's going to work. So it's got to be quite safe. So that most of the time, for most applications, you want it exactly like that. But for creativity, actually, you want something a little bit different, and that's why it's quite bad at being creative.
I mean, you've been studying this for the last few months, but so it's no place for me to spitball ideas. But what about just turning the temperature up so that it does start doing most likely things?
We obviously try it, and it's not very good at it. As an example, as a trivial example, ask it for a random color, it might come up with red. Ask it for another random color, it'll come up with red, because for it, the most random color it could think of at that moment is red, and the next time you ask it, the most random color it can think of is red. It just, and that's what we get. Think of a really crazy product, it'll come up with some funny thing, maybe a jet-powered skateboard. Think of another really crazy product. Oh, a jet-powered skateboard. It just gets stuck.
To be fair to the LLM, you'd probably get the same results with humans if you could rewind their brain state and put them in exactly the same state and ask them exactly the same question. They might come up with exactly the same response.
I don't think so. I actually think there's a vast difference between a human brain and an LLM. And I do not subscribe to the view that LLMs are going to be the answer to super intelligence and all the rest of it. It's not going to happen. But we
Hmm.
can get to that next.
So, I thought I'd maybe ask a little bit about evolutionary algorithms. So, for people who aren't familiar with AI, there's evolutionary algorithms are where you have a proposed solution or program, for example, to perform some task, and you make random tweaks to this program or solution and then measure it against some uh, performance metric that you want it to optimize. And then on the other end of the scale, you have gradient based learning algorithms where you tweak the program in such a way to make the metric optimized because you can calculate, if I tune this bit up or down, does it make the metric better or worse? So it seems like the gradient based methods are strictly better provided you have access to these gradients, provided you do know if I tweak this up or if I tweak it down, will it make it better?
I mean, often that's true because, and that's why you use things like gradient descent, where you can make all the necessary calculations. But that's why for genetic algorithms, we typically use them for real world applications where there's a lot of noise, there's a lot of distortion, there's a lot of unknowns, and you
Hmm.
can't. There's no derivatives. You can't do backprop. All you can do is kind of say how good is this right now. The other aspect of GAs is that they're population based. So, evolution doesn't just use one member of a population to test things. It uses millions. We often can't have that size populations, but we have a lot. And so we get to explore in parallel many, many different ideas and then mix them up. If a couple of ideas work quite well, we'll bring them together, we'll do recombination and mutation. So we're mixing up good ideas constantly and exploring in parallel a large space. And that's why it's pretty good. It's this kind of thing. And that's how nature does it.
So it's in one way you can think of it as a solution that works when you don't have gradients, and that makes it sound like a bad thing. But then the magic of genetic algorithms is that you do get these kind of creative solutions, really novel surprises in how the final program works. Has your study of genetic algorithms, has that informed your view of biological evolution, or have you met people for whom genet observing genetic algorithms successfully evolving solutions has changed their beliefs on biological evolution?
I don't think it changes beliefs as such, but it illuminates, let's say. So I've worked with a lot of biologists over the years, and I mean, there's an entire subfield called artificial life where
Hmm.
we use tools such as evolution to study life as it is and life as it could be. Yeah, we can perform obviously an unlimited number of experiments compared to biologists who each experiment takes them weeks or months or years and costs a fortune. So when we model different aspects of biology, including evolution, we can explore aspects that they struggle to. So yeah, we learn all kinds of stuff. I've spent a long time also thinking about and working with developmental biologists and figuring out how the complexity of living organisms actually develops from a very compact set of instructions in our DNA. That's very clever. So the natural evolution is a remark. It sounds simple, but it's a really, really clever process, and it's kind of writes its own instructions. DNA, RNA, proteins are all kind of making good use of the laws of physics, right down to quantum levels, to build organisms at quite a macro scale. And of course, all the levels, from the cells working together, the organs working together, the people working together in societies and ecosystems, species working together. So all of this from a quantum level up to really a global level, evolution creates.
Mm.
And that's way cleverer than anything we've ever made, including LLMs.
I suppose the natural world has a lot more computation than we have access to.
A lot, yes.
It's what is it? Something like a few microseconds you can simulate of an enzyme folding.
I don't know what the current state is, but yeah, anything that we think we've got in terms of computational intelligence is still a feeble and very, very, very primitive version of what happens in nature. So yeah, I do think there's a lot of hubris and sometimes naivety from computer scientists who think they've actually developed human level intelligence. They seriously haven't.
So, well, I mean, you cover this a little bit in the final chapter of your book, Artificial Intelligence in Bite-Sized Chunks. So this goes through the history of AI, and it covers what I really enjoyed is that it covers some of the neglected characters, such as the Ukrainian and Japanese scientists who first developed deep neural networks, and of course Furbies and their interactions with the intelligence community. So, what was something that really surprised you while writing the book and researching for the book?
I guess there are a lot of surprises, really. I mean, it's not just surprises. It's also it sort of shines a light on what we're seeing today. So AI is as old as computers. The first computer pioneers were also AI pioneers. The first description of a computer, a programmable computer, the von Neumann report, described how to build a programmable computer by calling it neurons. A lot of his description of how to make this computer, he was using the language of the brain because he thought of it as a mechanical brain. So all the way through, it's been the thought of computer scientists and engineers, if we make this amazing electronic brain. And then, every time, every few decades, the pioneers get really excited because, oh, we've done it. The first time was logic. Logic is it. This is how you do it. Within a decade, we've sold intelligence. We'll be able to do everything. We'll have robots running around. They'll be able to do every piece of work that a human being can do. Done.
This was around the time of the Dartmouth conference.
Yeah, well, kind of a bit later. By the 1960s, they were saying things like that. And these weren't stupid people. These were the geniuses of their day. Arguably clever than the people we've got today, to be honest. I mean, people like Shannon, amazing, amazing intellects. And yet they were still making these predictions. And we just saw it again and again and again. Every time the predictions were wrong because some fatal flaw came along. Every time we see the same cycle, that a lot of funding in its day, a lot of funding would come along and lots of companies would come along. And then something wouldn't quite go right and they'd all fade away, sometimes in a serious bubble being burst. Sometimes it would just take a little bit longer. So today, what have we got? Well, we've got the latest bunch of computer scientists getting extremely excited. We've got vast amounts of money going in. I have to say it's more money than normal in this cycle. And an awful lot of predictions and silly things coming along. And AI, once again, is forming part of our lives. Now, you might say, oh, well, this is the first time AI has had such a big impact on society. Don't think so. All the major computer advances, even aspects of our operating system actually came out of AI labs. Things like multitasking, which we wouldn't call AI today. Back in the day, that came out of an AI lab. There's an awful lot of absolutely bog standard computing stuff that was once called AI, and then it just became mainstream. In another few years, large language models will be saying, that's not AI, that's just something computers do.
Yeah. Well, it's the same with expert systems, as you argued. They just became normal software.
It's the same for genetic algorithms and all that kind of thing. They're absolutely mainstream stuff. 25 years ago when I started, it was like, and they were really fashionable then. So the GAs 25 years ago were the AI today. Right, they were the big thing, the amazing thing. And in industry, they were saying, oh, I'm not sure we can trust these weird AI things. You can't prove what they're going to do. What if they don't quite get the answer right when they optimize something? You can't prove that. It seems a bit dodgy to me. Fast forward 25 years, GAs are embedded in countless industries. They use it as an absolute standard optimization method through the steel industries to design to I've got scientist friends embedded in all these places, and I know very well all the different GAs going around the place. Absolutely mainstream now. So it's kind of what happens.
So I do like the fact that this look at history shows you that the current moment might just be like other previous moments of overhype in AI. But what gives me pause for thought is that at some point in the future, we will be on the cusp of building AI that is human level or beyond levels of intelligence. And that the reactions then will be exactly the same as they are now. There will be lots and lots of hype and people saying, we're on the cusp of managing it. So it's not that hype means that we are not on the cusp of AI. It's just the history shows that it gives no evidence whether you're on the cusp of AI or not.
Well, I also think it's things like human level or super intelligence or things like that. There's no coherent metric for them. I mean, as far as those pioneers were concerned in the 1950s, they had human level, if not actually superhuman intelligence already, because those machines, they might be the size of a massive room. They were doing mathematics far faster than any human being could do. But don't forget, in the 40s, 30s, and before, a computer was a person who computed. I remember my old grandmother. She had a very old dictionary, and when I looked up computer, that's exactly what it said. A computer is a person who did computing. So as far as each of these pioneers were concerned in their timescales, they had supercomputing. They had human level computation for their metric. It's just that from a, let's say, a space aliens metric, they might look down and say, well, what are these people talking about? These are primitive machines. They're, in their skulls, they've got extraordinary complexity working down to quantum levels that wire themselves up, that maintain themselves, that are very low power. And they think these vast warehouses full of machines that do unbelievably inefficient computations are human level. What are they, stupid? So it depends on what the metric is.
For sure, for sure. I think one way of operationalizing the metric is, do we have an AI that can do any cognitive text-based task that a human can do for the same price point per hour as a human could do? So it might require a lot more energy, it might require a lot more flops, but if it can compete with a human worker at remote work, then even if that's not human level by some definitions, it would revolutionize the economy.
Would it? But I might as well say, yeah, a good metric is a machine that can automatically perform addition and subtraction and multiplication and division far
Well, that's
faster
not going
than
to
a human
revolutionize
being.
the economy.
Well, I think it did.
Well, sorry, it did.
I think it did. Actually, I think having computers has much more revolutionized economies and world and everything. So yeah,
Yeah.
much more, much more.
Well, maybe I could turn that around and so it proves my point instead of rebutting it and say that if only being able to perform that task alone at a better price point than humans revolutionized the economy, how much more so would it revolutionize the economy if it could do any text-based cognitive task as a human?
Yeah, but the point is, it's not going to, because the problem with text is you can do amazing text processing, but language means something, and at some point you have to have an anchor to reality. The problem is, and this is why even today we have amazing automated translation by computer, but when it really counts, we have people. And why do we have people? It's not that computers can't translate the words and sentences and get a lot of the meaning, but it's that subtlety. Sometimes there's a certain history behind a phrase. There's a certain meaning. There's a certain thing that you get it wrong, you're going to really offend this prime minister or this person. You've got to have this world knowledge. You've got to have this actual experience of being alive, being a human being, and understanding all of these things. And that's not something that we've got data on. We go through schooling through 20 plus years about learning to learn how to be a human being. And that's changing all the time as our societies and everything else around us change all the time. It's a real moving target.
Mm-hmm.
At the moment, pure text processing ain't going to cut it. So whilst, yeah, it's a useful tool, just as it's a useful tool to have a calculator, it's not a world-beating, life-changing thing. And in some respects, I'd say it's something we need to be careful about, because, maybe this is a bad example, but I remember when I was very young, probably 1920, and I was doing a summer research job, and my interview, before I started, my interview with this old scientist was, okay, show me your maths. Show me how you can do long division. And so he gave me this horrible maths problem, and right in front of him wanted me to work through. I couldn't remember how to do long division. I mean, obviously the calculators, but even then, I was a computer scientist. I was writing code. How did I write out how to calculate this division operator? I couldn't remember how to do it. So he wasn't very impressed at all. Now, you have the same thing for language. And you're a journalist and someone interviews you, and they probably don't do this, but in front of them, okay, write a summary of this X. I'm not used to writing. I tell the AI to write for me. Why would I actually put words together? That's not something I know how to do. We don't want to get to that point. So balances, we need to know what we actually need from these AIs. And I think, again, that's partly why I'm dismayed with the way AI has gone today. That people have got it into their heads, oh, we must build a super intelligence. What must we? What do we need it for? Well, what either everyday problem or world problem do we need a super intelligence for? I actually think what we need to do is solve global warming. That's worth putting billions and billions of dollars into. That's a big problem. Trying to make something more intelligent, is that a problem? Is that something we actually need to do?
So solving climate change requires a lot of money, but it also requires a lot of intelligence, ingenuity, creativity to come up with solutions, green energy solutions.
Yeah, but bear in mind, and I'm aware I'm playing the devil's advocate here, but bear in mind the current AI systems are anything but green, right? The amount of energy that is being used in every stupid little call to these LLMs, and my God, there's a lot of stupid ones. I'm aware that people are now. It used to be that the internet was filled with cats, pictures of cats. Now the internet is filled with, AI garbage and fluff, and it's the number of calls to these LLMs where, frankly, a little bit of code would have done it. People are using LLMs to do basic arithmetic. These are vast computational machines using a huge amount of energy, and they're misusing them for the most trivial cases. And they're building more and more of these vast data centers, using more and more power, using more and more towns' water. It's quite horrific, actually. This is not the way we wanted it to go.
So I'll admit I'm guilty of using LLMs for extremely trivial tasks, including calculations when I can't find my calculator or get Google to load quickly enough. The way I would think about that is how much energy and water is being used per prompt. in the aggregate, it's a huge amount, but per prompt, it's something like 10 seconds of television or 5 drops of water.
That's no excuse, right? That's no excuse. It's basically excusing huge inefficiency. Just because we can't be bothered to do something else. It's just no excuse. The bottom line is, if you're misusing a technology for something, then you're misusing it. And that, sadly, I'm not pointing at you particularly, but most people who are playing with LLMs right now are effectively turning on their car engine and leaving it running. They're turning all the lights on in their house. They're turning all the taps, and they're wasting energy. And more money is being poured into it, and we're putting more and more things. So yeah, in terms of, is this useful? Is this what we need as a human society right now? I'd say the answer is no. And that's, to me, that's the biggest problem with the current trend in AI. It's not that we've found a bad solution, because I think we found some really interesting current algorithms. It's what we've done with it. And right now, what are they good for? Their image generation is fabulous for porn. It's great for clickbait. LLMs are spectacular for clickbait and for filling the internet with junk and for misinformation. All of these misuses are absolutely prevalent in our societies. And as you mentioned before, people are misusing them for counseling and getting really quite horrible results. These are all directions we didn't want the technology to go. I'm as disappointed in this as I am in the way social networks went. So social networks are an awful disaster as well. It screwed up all of our kids and gave them all kinds of neuroses, awful things. There's some fabulous good sides to them, but there's some awful bad sides. AI has gone down that road really fast, and that's really unfortunate.
Mm-hmm. So I think what this hinges on is these companies promise that superintelligence will solve a lot of problems, hinges on this idea that there is a prospect of them surpassing the current levels of tech and getting genuinely creative, intelligent algorithms that can solve real-world problems for us. So maybe we should talk a bit about why you don't believe we're on the horizon of that within the current LLM paradigm.
Well, I've got more than one answer to that. So I do believe that, used properly, the current methods are tremendously helpful for things like scientific use. They are really, really helpful at collating together and summarizing and showing us insights into the vast amount of scientific publications that we've already got. And in doing so, allowing us to progress faster than we otherwise could. They're able to take a lot of these results and let's say, kind of summarize, collate, and extrapolate a little bit from what we've got. Mainly as a tool for scientists, brilliant. As a tool for developers, also brilliant, really effective at teaching you how to program. Very bad at writing code, actually. If you look at most code written by these co-pilots and things, it's usually overcomplicated and inefficient and poorly done. But as a tuition aid, as a teaching aid to help developers learn new systems, really useful. And again, a lot of these things are very, very helpful at teaching us. Beyond that, I don't know what to say. I mean, I think as I said earlier, I think superintelligence is a misnomer, because it is already superintelligence, and yet at the same time it's not superintelligent. It just depends on your metric. I think, and I very much dislike some of these entrepreneurs who are, or business leaders who say we're going to solve intelligence, we're going to solve superintelligence. Yeah, you don't solve intelligence. Intelligence is not a problem to solve. Intelligence is a solution to a problem. That's the point of it, right? You only need intelligence if there's a problem that the organism needs to overcome. So intelligence is the solution to a set of problems. If you just say, oh, I'm going to make intelligence and I don't know what it's going to do, it's the wrong way round. It's, I've got this specific problem, I need something clever to solve it. That's how you should do it. That's what intelligence is for. So, and again, I think that's sort of the problem that we face for all of this. As we're increasingly finding, the most effective versions of today's AIs are the ones that are specialized, the ones where, yeah, we've got this specific problem. We want to do protein prediction. We want to I don't know, we want to predict what certain compounds will do inside our bodies from existing evidence. You know, there are very specific domains that we can then train up a deep model, and they become really useful and really effective. But not a general purpose one, because that's just nonsense. You should specialize, because that's, again, that's what intelligence is for. Intelligence, you know, our brains are not general purpose anything solutions. We try and use them for a lot of stuff, but you know, where did we evolve? We evolved on this planet through a series of very clear challenges. We had to become very adaptive, but you know, we have very specialized brains. Actually, we have a lot of our brain dedicated to talking. We have other parts of our brain dedicated to vision and other things like that. But why? Because that's the kind of world we live in. We have to communicate because we live in this society. Those are the sorts of problems we have to solve. But a tree doesn't have a vision center, and it doesn't talk a lot. It doesn't need a brain. And yet a tree is tremendously clever. And actually, we now discover kind of does talk, but through its root systems in the forest, you know, via fungi and other systems, there's a whole communication that does happen at a chemical level. And so they have their own kind of slow brains. Trees do send cries for help when they get attacked. There are kind of chemical signals. There's a lot of stuff going on in their kind of brain, but it's a different problem. And so it's a different brain. So that's what I'm saying. It shouldn't be, I'm going to make super intelligence, it's going to do everything. It should be, I've got this problem and I need something clever to solve the problem. That's how it should be.
Yeah, I think I'll push. Okay, so you might be making a normative claim about what we should do, but you also seem to be making a claim about what is in fact possible. And I would argue that while I agree other species have faced different problems and that's made them develop different solutions, they are, for the most part, fixed to solving those kind of problems. And in new environments, like an environment that's too hot or too cold or too much water or too little water, they fail miserably. Whereas humans, what makes us general is that we're able to solve problems that are not part of our...
I don't think that's true
Go
at
ahead.
all. At all. So you know, with you take any plant and you make a clone of it, you put it in a different environment, or even in the same environment, it's going to look different. Every plant adapts completely to its environment. Every plant is amazing at adapting to the differences that it will likely face in that environment. Same as us. We adapt tremendously well to the differences in our environment. It's just that we happen to wander about a lot. And so in our evolutionary history, our environments are relatively diverse. Relatively diverse. Too cold, we die. Too hot, we die. Not in the wrong kind of water, we die. Wrong kind of food, we still die. Right? So within a specific scope, yeah, we're very adaptive. Within a specific scope, plants are very adaptive.
Right, but our scope is larger. We can live on the moon.
We can't live on the moon. No one lives on the moon.
We can go to the moon. We can live on the moon for a few days.
But look, how do you define larger? I think you have to understand, just because we can talk doesn't mean we're better than a tree. Just because we pee in a toilet doesn't mean we're better than a dog. We're just different organisms. We've all evolved for the same amount of time on this planet. We're all equally good because we're all here. We're all equally good at solving the problems of staying alive. Intelligence is just something we happen to call something that this bit does. Our immune systems are tremendously clever too. Our skin is tremendously clever. The way we develop is tremendously clever. All these other forms of life are tremendously clever in exactly the same way, except in their own versions of it.
You really think there's no way to say that we're able to solve more problems than a tree can solve?
Depends how you define. I mean, a tree is solving a hell of a lot more problems in its domain than we do. So how do you count that? I mean, I don't even think it's useful to talk about that sort of thing. But this notion that somehow humans are the pinnacle of an intelligence thing, I think is nonsense. And there are many kinds of intelligence. Humans are very good at one kind. Other organisms are very good at other kinds. We are terrible at being dogs, right? And I'm an awful tree. Awful tree. So, we're just good at what we're good at.
Yeah, I suppose one way of formulating this or formalizing this might be through competition. So if you pit two species against each other, which wins out? And it's clear that we're just completely dominating the environment in terrible ways for other species. So in competitions, we just solve problems far more effectively.
No. By what you just said, we're absolutely terrible then. So, we are destroying our environment. We're making it uninhabitable. We're threatening to wipe ourselves out. We are clearly the worst adapted to this planet. We're clearly the most stupid species because we're actively killing ourselves in many different ways through sheer stupidity, frankly. So obviously there's competition, and there's competition amongst trees to survive in a forest, but they don't destroy their environments in the process. They don't do unsustainable growth that will kill everything else, and including themselves in the long term. That's what we're doing. So we're clearly way more stupid by those standards. We're we're by far the most stupid species on the planet. So you've got to understand that intelligence it is not about that, and it shouldn't be about that. And even if it were about that, we still haven't made anything that resembles that in our computers. We've made things that are really, really, really good today at looking at text and images, and that's really useful. Large language models are great at language, and image models are great at images, but they're not brilliant at most of everything else. And in this world and universe we're in, actually, most of everything else, there's a lot more of that than there is text and images. As much as we happen to like text and images, there's a lot more to life than those things.
So one of the worries about existential risk of AI is that we might create something super intelligent. Let's just put that term away for the second. But that's the argument, that we'll create something smarter than ourselves and it will outcompete us in terms of resources and access to the environment and pursuing its goals. But if I understand you correctly, you're saying that the problem wouldn't even be intelligence. If we create something much more intelligent than ourselves, then maybe it wouldn't go around destroying the environment and possibly extinguishing itself.
So, if it were that clever, yes, it might actually teach us a few lessons, say, well, this is how you're supposed to live, humans. Don't be so stupid.
So in that case, maybe the risk is different, that we instead create an intelligence that can outcompete us and through its stupidity destroys the environment.
No, I think that honestly, the real risk is, because we're not going to do that. The real risk is exactly what's happening. We create a quite impressive intelligence that we get overexcited about, and then we misuse it for so many safety critical or otherwise important applications that we end up killing ourselves or making our lives an absolute misery. And that's pretty much what we're doing. Um,
with AI?
yeah. Well, I mean, we've done it with many other technologies too. You know, social networks is the previous generation's example, but great idea, really absolute mess. The danger is we're going to do exactly the same thing here. So, you know, AI out of control, you know, it can screw up our kids, it can screw up our societies, it can screw up our democracies. It's possible, maybe not as much as social media can, because social media is particularly good at destroying societies and democracies. But AI is a really useful tool to help along the way. And so, yeah, that's the real danger. Not that the AI has any kind of autonomy, really, any kind of consciousness, any kind of intent. It's just that we're going to do it to ourselves using the latest tool that we call AI. And that's what's happening. Just look around you. So,
I agree that, and as I talked about earlier with the Adam Rayner case, that there are awful consequences that are very avoidable. And so it's a shame companies are going down this route. But I would just say, are you saying that the loss of control to autonomous AI is a lower risk or literally impossible?
I never say anything's impossible. It's just that no one has any idea how they might make such a thing at this point, and that
Hmm.
even if they could, that it would be any danger to us. I mean, right now, as any AI scientist stroke engineer will tell you, it's not easy making these things. You know, it's not easy. We try really hard. We spend long hours trying to make these things. And it's okay, maybe the salaries have got a bit overinflated. So we hear ideas of some people being asked to work at companies for multi-million pay packets these days. But at the same time, it's quite difficult, you know. The maths is pretty tricky, and it needs real persistence, and it's not easy to make them do anything at all. So the fact that we've got where we are is through real hard work. How in the world are we going to make anything that's so clever that it can somehow, well, I don't know how it's going to do it. It's got to stop us flicking the off switch. And I don't know how it's going to stop that, you know, because there's a lot of off switches, frankly. There's a lot of different off switches in a lot of different computers that it's running on. How do you stop us from doing that?
Hmm.
At what point will this super intelligence, this autonomous intelligence, be able to do that? Somehow move around across the network and, like some science fiction movie, and inhabit all of our different computers. That every computer's got an off switch, you know?
Well, just to take the metaphor, well, it's not a metaphor, but the hypothetical seriously, if it was in every computer and the only option was to switch off all the computers, that would be a global disaster for hospitals, GPS, and all other kind of
Yeah,
global
but
systems.
well, look, not if it's done quickly. I mean, the point is, it happens all the time anyway. Today we have hackers that get into major systems and lock them down and say, give us money, or the ransomware will screw up your systems. What do? They turn it all off. And this, unfortunately, has happened to hospitals. It's happened to major chains of retailers. So this is not unusual. So if an AI sees this and thinks, well, oh, they're never going to turn it off. Oh, yes, we will, because we do, just to ensure we don't lose money. If our entire existence is threatened, of course we're going to turn them off. So, you know, I don't see how it could ever be a threat, frankly. And equally, I don't see why it ever would be. Because at the same time, everything we do when we build these things is to try and make them useful. That doesn't stop people misusing them once they're out, but every time when we're trying to create them, we do it from the purpose of making them useful. So, you
Well,
know,
we try.
we do try. work it. I don't know how. Somehow someone's got through my airplane mode and is still ringing me. How does that work? All right. And there you go. That was an AI. Believe it or not, it really was.
So let's move on to a position paper you wrote for the European Parliament in 2018 called "Should We Fear Artificial Intelligence?" And the way I read this is a kind of defense of AI as a scientific pursuit when these existential risk scenarios became more popular. You talk about all the ways in which AIs are currently and can in the future make our lives better. So, what are some of the exciting, positive use cases you've seen for AI recently or that you're excited for?
I think one of the most amazing things we have from AI at the moment is that it's just is able to read a lot more than we can. So, you know, is if it's there and it's seen it, it can actually summarize it really well. And if there's a lot of it, it can do a really good job of picking out the salient points and the commonalities and bringing us these insights. You know, today, research is ballooned into this kind of monster where when I started 25, 30 years ago, there were just a handful of computer science papers published a year in my field. And if I wanted a copy, I had to do an interlibrary loan and get a hard copy sent. Today, every day, there are hundreds or even thousands of articles that people are publishing in my and related fields. It is not humanly possible for me to read them all. I can't do it. And the same in medicine, the same in biology of all disciplines, in chemistry and physics, you name it. We can't keep up. But the LLM can. The LLM actually can look at this stuff and can do a really quite intelligent comparison and check. And as I say, it's a great teaching aid too. It really educates you about a lot of stuff. I mean, there are obviously some provisos in this. I worry that if it doesn't know, it'll make it up. And that's always a danger. If you happen to ask a question that it really doesn't know the answer to, I'd much rather it said, I don't know, instead of saying, oh yes, I know. He's like the man in the pub who knows everything. I know all about that one. It's all about this, and then makes up everything, which is a classic LLM thing. Obviously, we don't really want that.
And not a failure mode humans have at all.
Oh yeah, I mean, of course we do, but it's not a pleasant side, is it? It's not what a scientist is supposed to do. So if we're using them for science, we want it to behave like a scientist. Frankly, don't make stuff up. And as I said before, I would much rather have specialist AIs that we focus on specialist domains, and then we get really good results from them. I mean, I've used some and shown that like image interpretation, it can be surprisingly good. You can show it images of things like buildings or architecture, apartments, and it'll come up with quite detailed descriptions about not just what's in them, but you can ask it about things like sustainability. What kind of radiators are these? What kind of light fittings? And then you can start making decisions about how you might need to upgrade a building, for example, to make it more sustainable. So there are quite useful insights that we can get that may not be novel, they may not be groundbreaking, but at the same time, the fact that it can automate it, it can do it at scale, it can do these things that most of us don't have time to do, and we don't have the resources to do. We don't have enough trained people to do. Same in medicine, looking at scans, looking at medical things. These are really, really valuable things. It's not inventing something new. It's not doing something a human can't do. It's just doing something that we can do, but faster and at greater scale. Really useful.
Yeah, so this report was fighting back against the existential risks when they were more popular in the news press or the odd business person such as Elon Musk, but they weren't really popular or at least vocalized by AI researchers. So when people like Joshua Bengio and Geoffrey Hinton came out and said that they did actually take these existential risks and loss of control risks seriously, did that come as a huge surprise to you?
No, as I
No.
said, because I've written the books on the history of computer science, you frequently get the pioneers of these methods, the very, very intelligent people, um, kind of losing track of what their methods can and can't do. And I do think I know Jeff. I interviewed Jeff for one of my first ever books, digital biology. Um, and as things have progressed since then, that was 20 years ago or longer. Um, as things have progressed, he's become deeper and deeper involved. Of course, he has. He's a Nobel Prize winner, but that doesn't mean he has let's say, retained the perspective that perhaps he needs. I'd love to have a debate with him sitting here, because he did a recent talk talking about these things. I think it was in the Royal Institution, something like that. I think I disagreed with almost everything he said in that. We don't have time to get into all of it, but the point is, I think he has lost sight of kind of what I was saying earlier, what intelligence is and what it's for. He's lost sight of that because
Mm.
he's too embroiled in it. There are some real dangers with AI, real dangers, societal dangers, some mental health dangers, all kinds of dangers, but not existential dangers, apart from us being so stupid that we just let an AI decide to press a nuclear button automatically or not, and in which case it might just decide to hallucinate something from Putin and do it anyway. Misusing them, for sure, we're in danger. But not because they suddenly pop up their own ideas to do it. We're not there.
But I suppose you're saying you disagree. You think he's lost track of what AI can and can't do, not what isn't plausible in the future.
I think more than that, he's lost track. He um, talked of large language models. I think I've forgotten the exact wording he used, but he talked of language being a model, and by forming these amazing models, using language, they were effectively understanding for real and really starting to get the hang of stuff. My response to that is, a model of what, Jeff? Because we model reality. When we use words, we actually have a grounding in the reality we live in. We know what a cup is. A cup is just not CUP cup. A cup is this. It's got solidity. It can hold liquid. It can break. It comes in all sorts of different shapes and sizes, which may feel different and have different temperatures when I touch them, and are made in different environments for different reasons, and there are different customs and how you hold cups, and different societies use cups for all kinds of weird stuff. There's a lot of stuff in cups, and it may understand a lot of language notions behind them, but it doesn't understand what that means in our world, because it doesn't live in our world. It doesn't have that data, and that's the bottom line. It's very limited in data. It's not multimodal enough. It doesn't have the sensory apparatus that we do. It doesn't have the ability to affect its environment that we do. So again, we spend all of our lives interacting with our environments. We don't just receive information, we affect things around us. It's embodiment. We are very embodied in our environments, and that's how our intelligence works. LLMs are not embodied. They don't have that level of intelligence.
They can affect the world though. If I let it loose on my computer and it starts browsing or writing code, then it is affecting the world. It can chat to other people online.
In a very indirect way, but it's not it's not connected directly in the way that we are. It doesn't actually understand that there is a planet. It doesn't understand the way the things are in reality. It doesn't have that kind of existence. It lives in its own world. And yes, it may understand its world. It may become very clever about its universe of documents and text and things like that. It may become much cleverer than us in that world. But that's not our world. So an LLM may become super intelligent, and may already is in its world, but it's not. It shouldn't be compared with us. It's not a human intelligence. It's not like our intelligence. It's not the same. It doesn't work in quite the same way. It doesn't live in the same environment. And so you've got to understand that as soon as we try and take an AI and make it more embodied in our environment, like an autonomous vehicle, generally doesn't work very well. We have spent decades with countless years of testing of these autonomous vehicles. They still don't work very well. Our world is way more complex than the world of text and documents, astronomically more complex.
Yeah. I'm just gonna push back a little bit again. What's it called? There's this group in Russia of hackers that also do social influence. I can't remember what they're called, but they have done incredible bad things on Facebook, for example, and this is entirely through text by posting suggestions of protests, often pitting two opposing
Of
groups
course,
together against each other.
you can influence at arm's length, with very long arms. At arm's length, you can have some effect, but it's a long causal distance away. It's not like us, where I can touch something and I can feel it. I can knock this cup off my table and break it, and instantly I get feedback as to what's happened and the noise and the sound and the effect. It's a very direct connection, and it's something that, as I say, it's years for us to learn how to deal with all of this input in this world, because we live in such a complex world. Our robots can't even walk. Our most advanced, fabulous humanoid robots still fall over all the time because our world is so complicated, and that's walking on a flat surface. So you cannot underestimate how complex our world is, and in comparison, how simple, albeit there's a lot of documents, the world of documents that things like LLMs exist in is unbelievably simpler. So therefore, yes, they may be very clever in that world. They are not clever as life is.
So you give three arguments in this report to show that the existential risks are fantasy, and I just thought we'd go through each of those.
I can't remember what I wrote. Let's see if I still agree with myself. Okay, this was some years ago. I hope I still agree with myself. Right.
Okay, so I'll paraphrase a little bit, but first law of AI, you've got challenge begets intelligence.
Oh, I pretty much said that earlier, right? Okay.
Yeah. So a little quote just to flesh it out. So we've got intelligence only exists in order to overcome urgent challenges. Without constant new challenges to solve, AIs will not gain another IQ point. AI will only be as intelligent as we encourage or force it to be under duress. So my question for this is, why can't AI set its own challenges?
Well, I kind of went into this earlier, because AI is not creative at all. So yes, of course it can, but it'll just come up with rehashes of things it's already thought of. The only way it can grow beyond its current limits is to have challenges that are beyond its current limits, which by definition it can't think of. So no, it's not going to be very good at that. What you really need is something from the outside world. And frankly, I think what I was getting at in there is it's always taken humans to do that. Human engineers are the ones that basically give it the challenges to make the things in the first place. So it's always been us that set the problems. And about the only way you could make this happen is if you could connect the real world properly through a good suite of reliable sensors to an AI, and let it face real challenges, real existential to it challenges, all the time, and then it
Mm.
might have to learn something.
So as a very simple but possibly quite present example, I could imagine a coding AI, an LLM fine-tuned for coding that's learning how to code better and better, and it's in an environment, and it codes away, and occasionally things don't work, and you could scaffold it such that it notices when things don't work, tries to describe what went wrong, and then fine-tunes itself to not make that mistake in the future. That would be a kind of recursive self-improvement, or self-improvement at least.
The trouble is, it doesn't work. I've used these things extensively, and every time, particularly, I'm a researcher. I always ask it to do things it's never heard of, and the problem is, it can never do them because it's never heard of them. So every time it hits a point where there's no examples of this, no programmer has ever thought of this problem before, no one's ever got an example, can't do it. It just gets stuck. If it's very, very, very similar to something it's seen before, then it'll have a few guesses. Usually comes up with an overcomplicated answer, which often still doesn't work. But it almost always takes a proper programmer, a real person, to come in and say, okay, yeah, see what you're trying to do, but you don't need that, and we should do it this way around, and then we can probably make it work. So they're not creative enough, and they can't do that, and they're also no good at testing. So because you've got to do enough testing to make sure the code works anyway. So yeah.
Yeah. I suppose I agree that LLMs are fundamentally not particularly creative. They're a tiny bit creative, but not very much. But the RL can lead to greater creativity, reinforcement learning, and genetic algorithms can lead to much greater creativity. So I could imagine a system where you pair these three together and you could end up with an AI. Like, it's not in principle impossible that you have an AI that sets its
That's
own
kind of
goals.
proving my point. That's bringing in stuff from the
Mm,
outside, right? That's a challenge coming in. That's the reinforcement learning. How good are you at solving this problem? That's the challenge. So that's kind of proving
hmm
my point. If with the appropriate feedback, you give it a challenge, you say how well are you solving the challenge, and you get better and better at it through reinforcement learning. And now GA is a kind of reinforcement learning anyway. Then yeah, the challenge is helping it to grow. But without that, it generally won't.
Yeah, I feel like maybe the distinction we're hitting at here is the difference between being able to do something novel and being able to notice that you can't do something novel. And I would argue that an LLM would have the second capability, and by being able to notice it, might, with the aid of other learning algorithms, be able to train
I
itself to do that.
don't know. It can only notice it if it's had feedback to say, either number one, you keep saying the same thing all the time, so you're not creative, or number two, you're just not able to solve this problem, are you? It just doesn't work. And
Yeah.
that is this kind of evaluation that you need. You need a reinforcement learning thing. So you need to say, I've got this problem X, and you're not able to solve this problem, are you? It's a bit more challenging than you've ever had before, so you're going to have to do something to improve yourself. And that's that challenge I was talking about. You need to have a challenge to make it overcome it.
Okay, so that was the first law.
I still agree with myself. Good. Okay.
Good. Okay, 1 out of 3 so far. So the second law you've got is intelligence requires appropriate structure. And then a paraphrase here is the creation of ever greater intelligence, or the ability to handle ever more different challenges, is a continual innovation process with the invention of new structures required that are tailored to every new challenge. So I think this definitely looked true in 2018, where you had specialized algorithms for specialized tasks. But even as early as 2022 with LLMs, and let's leave LLMs aside for a minute because we've talked enough about those, but a system called Gato, just a single neural network from DeepMind that could play Atari, caption images, chat, stack blocks with a real robot arm, all using one neural network, which is a transformer. Does this not go against the idea of you can only build specialized intelligences?
Not really, no. I mean that's an example of a nice self-learning neural network, but you know, still in almost every application, large language model, image model, we still find the best results are when we specialize just a little bit. We specialize. We have visual centers. We have cortex. We have hippocampus for memory. We have very clear centers. Do you not think evolution would have just used one type of neuron and one type of neural network if that would work? Because that would be way easier to evolve, right? If just one structure did everything, of course it would have found it. Instead, it's come up with highly complex and highly specialized centers. Why would it do that? Because it works better. So the bottom line is, you could get some results from a do-it-all kind of generic neural network, but there certainly won't be the best results. And we know this from no-free lunch theory and all the other things. If you want proper, efficient, good results and good, let's say, examples of intelligence for specific problems, you need dedicated intelligences, dedicated modules for those ones.
Yeah, I don't agree. I think LLMs really unified so many different tasks in natural language processing and actually beat the state of the art for many of those specialized tasks by training a very general algorithm.
So what?
Well,
I mean, do you really think those tasks are representative of the complexity of problems in our world? They're really not. I mean, they're a tiny subset of problems that computer scientists decide to set them. They do these things. Are they able to drive a car effectively? No. Are they able to control a robot such that it can run around and do anything we can do? Of course not. It's again, as soon as you hit the real world, falls over, doesn't work. Yes, it can do a lot more things than other methods do. So could the genetic algorithm. That's why it was so good. Almost any problem with no gradient, yeah, you could slap a GA on it and it could come up with a pretty good answer. It's not the best answer for everything, but it was a great generic optimizer. That's why GAs were so popular. They could do so many different things. Does that mean it's the answer to intelligence? No. It's just a good optimizer.
No, I agree with that. It doesn't show that it's the answer to intelligence, but it maybe points to a trend that more and more general approaches often beat state-of-the-art specialist approaches. And if that trend continues with more and more data.
Yeah, but they don't, though. But they don't. As soon as we actually, I consult for a lot of different companies, and a lot of what they want these days, obviously, is they want AI embedded in their systems. And as soon as we take one of these amazing AIs that's beaten all the different tests and can, I don't know, it can pass the bar and it can do every exam under the sun and it can play Atari games or whatever it might be, and we try and solve a very specific problem that this company might have, we find it can't do it because it starts hallucinating, or it starts doing something crazy, or it starts doing something else. And we really have to work hard to make the things work. And sometimes we just have to turn around and say, look, this is not appropriate for an AI. You just get a human being to do that bit. So am I impressed at the current state of the art? Yes, it's improved a lot. Is it as good as everybody says? No, it's not. Because when you actually try and use it to do useful work in the real world, they still don't work a lot of the time.
I suppose I was thinking of the specific case of GPT-3, which turned out to be a state-of-the-art sentiment classifier. But I take your point completely that when the rubber hits the road and you get to real-world problems, it might nevertheless be useful to have a specialized system for your particular problem.
Yeah, almost invariably it is.
So is that 2 out of 3?
Probably. What was it again? Is it the
Um,
specialized structure? Yeah, I think it
second
probably
law.
is. Okay, I'll agree with myself again. Good. Okay. Right.
Okay, so third law of AI. Intelligence requires comprehensive testing. And here you illustrate it with a quote from Marvin Minsky, so big shot AI researcher from the 20th century. And he said, "There's so many stories of how things could go bad, but I don't see any way of taking this seriously, because it's pretty hard to see why anybody would install them on a large scale without a lot of testing." I would say maybe that one's held up the worst, given that people have, in fact, deployed on large scale systems that have not gone through sufficient testing.
So this goes back to my point earlier. The biggest danger is people are using these systems inappropriately, and one aspect of using them inappropriately is they don't bother testing them, right?
Mm-hmm.
So most of what I do when I'm helping other companies is we don't just run the things once, we do thousands and thousands and thousands of checks to make sure it works. And most of the time, this is what I mean by I say it doesn't work. What I mean is maybe 2% of the time it does something nuts, and you can't have that. But if that's important, I mean, if that's really important, if the nuts thing is so nuts that it might make your company bankrupt, you can't have that. Or if the nuts thing might kill one or more people, you can't have that. So, that's why generally writing code is safer, because we know what the code's going to do, and we just don't always know what this AI is going to come up with sometimes. You think you've nailed it, and then suddenly the same input, and you see what is it saying? What is it trying to do?
Mm.
So that's where we run into trouble, and that's why testing is so important, because the inconsistency, and people don't do it and they don't know. That's the terrifying thing. They don't know. They think this thing is amazing, and a lot of the time it is, and sometimes it's really not. So testing is tremendously important. And I think I probably make the point that the more complex you make it, the more testing you need to do. And again, we see this every time we've embedded AI in one bit, and then maybe they update the model, and apparently it's better now. And guess what? What we just embedded doesn't work anymore. All this better AI is not better for us, because now it does something completely crazy. So you've got to do even more testing.
Yeah, you make the good point that as the possibilities for the AI become larger and larger, you have to do more and more testing. And language is the perfect example of that. It's completely open-ended. And rigorous testing would be extremely expensive, such that these companies have taken shortcuts on it.
And that's the issue, and that's, if you like, why it is so dangerous at the moment. That we've got agentic computing, which is the latest really wasteful way of using AIs that to try and automate all kinds of systems in companies and all kinds of processes. And it's based on the assumption that these things are going to reason consistently and sensibly, and make sensible decisions. And maybe when they were set up, they looked like they were. But then if a model gets updated, or a little bit of unusual data comes in, or even if you just run the thing a 1,000 times, you see that sometimes it's not working at all, and sometimes it's gonna be downright dangerous in what it does. And the trouble is, once it's started down that route, as we've found with the poor people who use it for counselling, once it's gone down the wrong road, an AI doesn't generally apologise and say, "Oh, silly me, I got it wrong." It just carries on. No, I'm right. No, I can make up research papers that prove I'm right. So, yeah.
So to finish, I'd like to ask, What areas of AI research do you think people starting to study the subject could focus on if they want to be sure they're going to have a positive impact?
I would it's hard for me to answer that question. I think I would probably turn it around, and I would say, what problems in society are most important to be solved right now? And pick one that is the most useful and meaningful. And then if you're interested in AI, think about how AI might be able to solve that problem. And if the AI is not good enough, then think about how you might improve the AI to make it able to solve that problem. Don't think about just randomly making a super intelligent or clever AI, because that's just that route leads to disaster. Have a reason for it first. Have a proper application that's useful. You know, educate our children in a safe and useful way. That's a good domain. Global warming, you know, medicine, food distribution, making democracies better, more making it so politicians can hear the views of their population in a more representative way, making social media less harmful. You know, there's a lot of issues that need problems. And AI might be able to help if we really think about how we can apply it, and maybe we need to improve AI along the way to do that. But don't do it the other way. Don't make some clever AI and then worry about what to do with it next, because it's only going to be used for porn or something stupid.
All right, my guest today has been Peter Bentley. I've really enjoyed chatting. Thanks so much for coming on.
My pleasure.